Hey friends, it's Scott Hanselman. I'm going to take a moment in the middle of the show here and thank our sponsor, Tuple. I was chatting with Johnny Marler about Tuple. Johnny, what kinds of developers or teams use Tuple?
Yeah, with Tuple, it runs the gamut. So I think the common thread is people who care about quality. So we've got small teams like Tailwind and Laravel, but we've also got big teams like Shopify, Stripe, and Figma. And of course, we use Tuple all the time. We're a small bootstrapped company, and almost everyone at Tuple is an engineer, even our CEO. And I think that's how we catch all the little things and why Tuple feels so different, with like smooth annotations, no clutter UI, and the ability to just do anything with just one click. So yeah, I think it's people who basically obsess over pairing, obsess over quality. And when you use Tuple, you're supporting an independent company that didn't take any VC backed money. So yeah, it's a lot of people. It's anywhere from 2-person shops to some of the biggest engineering teams in the world. And I think what
Yeah,
they all have in common is taste.
they all have in common is taste.
Yeah.
Yes. Who uses Tuple? People who are awesome. That's actually kind of true. You can check them out at tuple.app. It is the best remote pair programming app on Mac OS and Windows, and it's worth checking out. Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes. And today I'm chatting with Marcus Fontoura. He is a technical fellow at Microsoft in Azure Core. He is a distinguished member of the Association of Computing Machinery and a member of the IEEE. How are you, sir?
I'm doing great, Scott. And, thanks for having me.
Thanks for having me. I had the pleasure of reading your new book, an early copy of your new book that you gave me to review called Human Agency in a Digital World. You'll be able to get this wherever books are sold, and you can also check it out at fontoura.org. When you know that there's a book inside you, like this book was inside you and you needed to get it out, what was that moment? When were you walking around or at work and you was like, I think I have a book in me I need to get out of me?
This is a great question because I always thought that our lives are so immersed in technology and the broader society doesn't really have the grasp and the understanding that we should have about technology, and we should treat that we can participate in technology and not be just bystanders. So my daughters actually prompted me because they are asking a lots of questions about AI, the futures of their future, the futures of jobs and education. And I said, maybe it's a time that somebody that works in technology has an attempt to write a book that will try to demystify some of these concepts to the broader audience.
Mm-hmm. Who is the audience, though? When I read the book, I felt like you don't shy away from challenging questions. You don't shy away from some of the math. The altitude changes. Sometimes it's high level and it's philosophical, and sometimes it's low level and it's math. Would I give this to my non-technical parent, or would I give this to my son in university?
I hope to both. I think though, it has to be somebody that is interested in technology and curious about technology. Sometimes I try to go deeper, not for the sake of going deeper, but just to explain the key concepts that that I start building throughout the book. So the book gets, I would say, progressively more technical, but I think you can even view some of these deep dives in some of these core technical aspects of the book more as illustrations, because my main motivation is to give enough information that people can start reasoning about the systems at a high level. So we can read it trying to understand every little comma there, or you can read it trying to understand the broader framework. So I hope it appeals to both levels.
Mm-hmm. How much has historical context helped? I've mentioned this on the podcast before, that I'm on the other side of my career in that there are fewer years in front of me than there are behind me. And, you were at the forefront of object-oriented design. You got your PhD in 1999. You've been here while it got built. You've worked at Microsoft, at Google, at Stone. You've made the cloud, right? You're working on Azure Core right now. Things that fundamentally changed the world didn't exist when you started in school. How did that historical context inform your perspective on human agency in the digital world?
I think it gives me the sense that this is more of an evolution than a revolution. If you're not paying attention and then you're just looking to it and start reading about AI, you think, oh my God, AI is something revolutionary and is really going to impact our lives. If you are tracking how technology has been evolving over the years, even in the early 2000s, when you did the first automated machine translation software, and then IBM beating Kasparov like in chess, and then Jeopardy, and then all the evolution even as text processors, right? This is one thing that I say in the book, that in the beginning when you wrote in word processor, there was not even spell correction, and then we evolved it to now we have spelling correction, now we have grammar correction, and now even we can write full paragraphs for you. But this is an evolution, and the the advantage that we have lots of data because of the web. We have lots of data online. We have lots of processing power now, and you're going to see more and more progress towards amplifying these AI technologies. But the foundation is not very different than the foundation that we had for web search or for machine translation in the early 2000s, even in the 90s.
One of the things that I noticed throughout the book, this is kind of my interpretation of what a through line was, is there was a through line of efficiency. You talk about how a lot of personalities and a lot of programmers and software systems and organizations are obsessed with efficiency, and sometimes they think that efficiency is going to reduce waste, but then it goes and creates fragile systems. So there's kind of this waffling back and forth between being efficient and being fragile. Do you believe that companies can over optimize, and then in that process they've optimized themselves into fragility?
I believe so, but I also believe that we learn a lot, right? And one of the things that when you think about fragility in computer systems is a little different, right? Because if you are trying to build a robust bridge or a robust house, we are thinking about building a solid house or a solid bridge that will weather anything, any storm, and then will be super solid. In computer systems, when we want to build reliable things, we learned that the approach is to assume that you have unreliable parts and engineer resiliency on top. And that's, I think, was the evolution when we started seeing better networks, connecting more and more computers together, larger systems, more data. And one of the quotes that I say in the book is Leslie Lamport, that he said that a distributed system is defined when a computer that you don't know about crashes your system. And I'm paraphrasing here, but we are learning how to build resiliency in the presence of larger and larger distributed systems. And this is to me is fascinating because it's very different than traditional engineering. What we do in the digital world is very different than traditional engineering. Is almost like building a house that because it's able to be up, even if some walls crash and are rebuilt really quickly, it will be more resilient over time. So it's very interesting to view it from that perspective.
And to just call out who you mentioned there, that was Leslie Lamport. I actually had him on the podcast in episode 790. He's the winner of the Turing Award, which is considered the Nobel Prize of computer science. And the quote you're referring to is that a distributed system is one where the failure of a computer you didn't even know existed will render your computer unusable. And I think we can all relate to that. It's always DNS, as they say. Now, the title "Human Agency in a Digital World" it really is about preserving human judgment, which we hope is going to be not fragile. And it feels like computers are focusing on being efficient, while human judgment really should focus on keeping things strong and being what you call anti-fragile. But then when you introduce AI, which is supposed to be the thing that allows us to deal with ambiguity, where does human agency come in? Like, how am I needed then to keep things anti-fragile if the AI can do that for me?
I think one key point that we need to learn together is what we want these AI systems to do for us, and then and how can we cooperate with AI systems better, and how they can augment our agency. And they we want AI systems to be designed to amplify our humanity, right? So, like, for instance, a simple scenario is like, if you had and of course, like, that is like a out there, but like, I'm just wanted to be thought provoking. But like, let's say if I had a perfect robot tutor that could teach your kids to go to Harvard, but you had to delegate the education of your kids to this robot. Like, would you want that or not, right? So I would say for myself, like, even though I am fallible and not probably the best tutor in the world, and I cannot guarantee that my kids will get into Ivy League schools if they follow the Marcus tutoring style and not the perfect robot tutoring style, I would still want. There are some activities that I feel that are inherently human and we want to do, and I think there are things that are probably activities that we don't consider that, like, they define us or that they enrich our experience. Like, be it like anyway, like grammar correction might be one of those. So it's great that AI can do that for us. It's great that AI can search all the catalogs of all books in Netflix and give us a reasonable suggestion. And that's a really good use of AI. And then I think there will be uses of AI that I think we need to, as a society, think like, what is the direction that we want to take those. One of the things, Scott, that we talk about is like use of AI for developers, and that's one topic that we're super interested in, and for me is near and dear to my heart too.
Yeah, so we can talk about that a little bit, because one of the other things that you're known for is kind of thinking deeply about engineering culture, about rebuilding engineering culture at different companies. You've gone to companies and flattened management. You've reintroduced the idea of a strong individual contributor. You're, in my perception, you are applying stress to organizations, looking for the brittleness, and then trying to prevent that brittleness through stress, right? The idea is that you work out, you break your muscles down, and then you build them back up stronger than before. It's kind of this bottom-up innovation. With the innovation of AI into our lives, I worry somehow that people with fragile understandings of how systems work are going to have only their fragility increased. Senior engineers become more senior, and junior engineers maybe fall by the wayside, and that worries me.
Yeah, it worries me too, especially in the current evolution that we are in AI, right? I think the systems will get better and will do more, but it has been an increasing evolution. Like, since the early innings of computing, we are always looking into this task of, like, how can we make the job of the programmer easier and easier, and so that the programmer can focus on the business logic or the really important concepts that really capture the problem that they are trying to solve, and not all the glue that we have to put together. And I think this is a great evolution, and I think AI can really automate a lot of that glue and make the life of the expert engineer even better. I am afraid, like you, that junior engineers that don't have that experience and still don't have the key knowledge on, like, good patterns and good anti-patterns and what to look for in good code, um, AI will not help them as much, right? So this is a key problem that we are living on right now. And then I think it's fascinating because I'm sure we have like good solutions, but we have to be super intentional about it, right?
Yeah.
And being intentional is not just like give AI to everybody and hope for the best. I think we really need to have a plan.
No, I really appreciate that perspective. The idea of being intentional and is so important because right now it feels like we're just throwing AI at everyone and hoping it'll work out. And that throwing sharp sticks at people will just make them poke themselves and their friends in the eye. And our mutual friend, Mark Rasinovich, has kind of similar concerns. And one of the things that he was mentioning to me was that some people seem to think that an infinite or a very large context window would allow AIs to look at a system like Azure, like a large enterprise system, something with billions of lines of code, with an incredibly deep stack, and somehow look at that. But I think that's silly. I think that the context window of a human experience, my 30-year context window, your 30-year context window, is interesting because we're paging in and out. The human brain is paging in and out from deep storage. When you like have a problem and you go, when did I think, and then your brain somehow pages from deep storage into your local context window, like, yes, I've seen this before. We are so good at pattern matching. I wonder if that's going to be our superpower, like human judgment and experience over many years, paging in and out of local storage is my superpower, and the AI won't be able to create that.
No, I agree, and then I feel like there is this part of the book that I talk about AI being stochastic parrots, right?
Mm-hmm.
Because a large language model is a model that read for like thousands and thousands of years and basically remember everything and store everything in these like trillion parameters that these models have, and we don't have that super memory, but maybe that's to our advantage because then we can step back. We are not just trying to pattern match. We are really um, taking a step back and then thinking through the end-to-end solution, the system thinking. And I think encoding system thinking in AI, I think we're a little bit far away from that. Maybe we'll get there, but like current generation of AI systems like are not there yet. So I think we need to really value like the art of computer science, the art of programming, and how to keep that alive and how to communicate that to the newer generations.
There was an article, I think, in the New York Times a couple of days ago where someone said that they were concerned that if we push AI too much in education, that people will become subcognitive, meaning that they just won't even think. They'll just go with their gut. And if a fact doesn't feel good, well, I reject that. I'm not even going to think about it. And I worry that we're going to unleash it on people so quickly that fragility of knowledge itself will be forgotten. Like, I'll retire, you'll retire, we'll pass away, and people are going to forget how all these systems work. Now, you work on Azure Core. You have built distributed systems since the first time you probably put two computers together and made a round robin DNS. This is a silly question, but how much of Azure's architecture can you hold in your head, and how many sections of the cloud you just have no idea how that works? How deep is your stack?
I would say that I probably for Azure, I probably hold like a very shallow understanding of like a very shallow understanding of like the end-to-end system. This meaning that I don't understand the details of many things, and there is a core part in the infra that I think I have a deep understanding, and I would think that the architects that put the systems together will be like me, right? Like there will be our storage architects that know a lot about the storage, but then they don't know much about how the networking systems are configured. Because I'm doing this role of like end-to-end architect for Azure. Maybe I'm even more shallow than most people in the details of each one of the components, but I have a pretty good understanding of the end-to-end flow of things, and I can dive deep in some areas, but I would say most of the areas I can't. And then I feel that. And this is the beauty of humans, right? Because humans also are different. there are humans that will be more like me, and there are humans that will be very deep and really understand like that narrow component. And that's the beauty of composing uh, heterogeneous teams with people with different backgrounds, different interests, because we can complement each other and build really a strong, anti-fragile software organization. Now, all AI agents are the same. Like if they are based on the same transformer network at the end, like they are all the same. They all have very good memory and very weak processing capability. And then I don't want I want an AI agent in my team, but I also want people with other world views, if that's the word that represents it.
That really scratched a certain part of my brain right there, because you're absolutely right. Like, we know that having separate responsibilities, having deep specialization, having diverse teams of people from all over with different expertise, heterogeneous teams, by definition, make scientifically good teams. But if I were to make a multi-agent workflow and they're all based on the same model and they're all based on the same architecture and they all do the same thing, I've effectively hired one person and cloned them and called it a team just because I gave everyone a different job description. But that's not a heterogeneous team. So arguably it won't be able to operate at a high level of quality. It would be a fragile team.
Yeah, it would be more fragile than a human team, right? But with maybe a super programmer in it, but
Yeah.
albeit we have a super programmer, but it's still, if you look at the organization as a whole, it could be a fragile organization.
Yeah. One of the things that you talk about that you seem to be really excited about in the book is the idea of virtuous cycles. You really believe that if you can start a flywheel, you make investments in the right thing, and then maybe an investment in the market, an investment in your people, an investment in productivity, that you start a virtuous cycle. Can you talk a little bit more about why virtuous cycles are important?
When I look at organizations, and then one of the things that I try to do in the book is like to look at organizations from the lenses of computer science, right? If I was going to program an organization, I want an efficient organization. And what does that mean? I want people to be working on the latest and greatest technologies, so that they have like great tools, so that they feel productive. And um, and if they feel productive, they can achieve more with less. But then I don't feel that like, oh, because I'm achieving more with less, we should have smaller teams. And it's not the argument. It's more when we achieve more with less, we can do more. And doing more, like we are just growing the pie. And then we do more, and then this flywheel keeps going up and up, right? So we do more, we invent new technology, and then we are more productive. We have more resources to invent yet more technology, and we are yet more productive. And then I think that's like the holy grail for me. And um, and, and I think to me it's like almost like a super obvious idea, right? But I feel people don't have that in their heads, right? Like they're saying like, well, let's just become more productive. And then I said, okay, becoming more productive, you are producing more with less. What do you do with the value that you generate? How do you invest this value? And my key thing, my key mantra is that we should invest this value in innovation, because then if you don't reinvest in innovation, basically you are not putting it to a good use.
Yeah, that's a great point. And also that the human in the loop is so important, that human agency, like literally in the title of the book, like we're making a thing more productive. For who? For humans. Why are we doing this? How did we improve their lives in the design of this? How did we make the engineer have more fun, enjoy their work, get to be more creative? And the products that we create, are they less fragile so that people are going to have a better experience? And you call out that where machines scale in being efficient, humans need to really amplify being adaptive, and you know the tools need to be secondary. The human needs to be first.
Yeah, I love machines. Right, one of the things that I repeat over and over in the book is that machines are very good in doing calculations, and in fact, it's the only thing that they know what to do. Right, like they didn't know how to do. They don't know how to do anything besides computing integer functions. But the advantage is that they do it very fast, very precisely, and they don't complain. If you ask a human to keep computing the same matrix over and over, they'll get bored and start making mistakes right away. So I think heterogeneous teams that is composed of machines and humans, we should delegate the humanity to humans, and let computers do what they do best.
Mm-hmm. One of the sections I really, really enjoyed, because we talked a bit about anti-fragility, and Nassim Nicholas Taleb wrote about that in his book Anti-Fragile. But you have a section called Laws of Physics, which I understand, and Laws of Fiction. What are the laws of fiction?
Yeah, and this concept, I am referring to fiction as described in *Sapiens* by Yuval Noah Harari, right? That we have our physical world that is governed by biology, chemistry, physics, and then we have our virtual world that is things that we invented on top, like stuff we invented, like cities, wealth, money, police, and all those things became an integral part of our lives. But they are really inventions of humankind, right? Like they are not really. Um, I can remove a law from the Constitution, but I can never remove the law of gravity, right? So I think sometimes, like when you're thinking about these systems, and one of they become the computer systems we build, they become so ingrained in our lives that we start um, thinking that they are real, that they are really part of our human nature and our physical world, right? My daughters were saying, like, I cannot live without TikTok when TikTok was about to be banned, and I said, like, you can absolutely live without TikTok, and then. We cannot live without water, you cannot live without gravity, but we can live without TikTok. And then that whole discussion is related to what we were talking about before, that we should think about which computer systems do we really want. And then one of the things that I mentioned was the impact of social networks on teenagers' health. And although there are very, very good applications and positive applications of social networks, not all applications of social networks are positive. And we shouldn't take them for granted. We should, as a society, when we understand these systems, have an opinion and then claim, like, do you want those things in our lives, or we don't want those things in our lives?
That is really a powerful way of thinking. Like, I can see people maybe listening to this podcast or reading the book and hearing the word fiction and having like a negative reaction, and then they would stop listening. But if you think about the two kinds of myths, right? Like the one that's physical reality, gravity is not a myth, it is a thing, it's a law. But then if we all have the same hallucination, if we all believe in the shared mythology, like you say, a city, there's physicalness to back it up, but it's just a giant village, and a village starts with one house, and then your in-laws move into the little hut next to you, and the next thing you know, you've got a city. The idea that my children exist in a world where pocket supercomputers exist, like, I remember when this didn't exist, which brings me back to that conversation from the beginning when I asked you, like, you remember when there was no cloud, and then someone had the idea for a cloud. We all made a cloud. Now there's multiple clouds, and there's a whole generation of people who believe in that myth that the cloud is required, that it was the thing that met the moment. And now we think that an AI is arguably a myth, as well as the anthropomorphizing of AI and people feeling like they have a relationship with an AI. It makes me wonder what the next shared delusion is going to be, or the shared digital myth that's coming after AI.
Yeah, and even our relationship with AI, right, Scott? Because I feel that a lot of people think about AI almost coming from this colonization mind frame that, like, we had Spain conquered America, or now we have, like, maybe the humans will domesticate AI, or AI will domesticate the humans. and it's pretty dated viewpoint, and to me it's a pretty uninteresting viewpoint, and I'm actually much less concerned about that than like us really trying to understand what we can do with AI right now to really have a positive impact in the world, right? There are so many problems we want to solve. We want to solve climate change. We want to solve um, income distribution. We want to solve social mobility. We want to solve transportation. And AI can play a huge role in all those things. And if to me, it's much more interesting to think about those scenarios that AI is applied to a scenario that is really impacting our humanity. Like, let's fix transportation with self-driving cars, or something of that nature, than to think that in a few years AI will dominate the world. And it's a pretty far-fetched and uninteresting discussion.
Yeah. It's interesting to watch people argue with AIs when they'll say something like they'll go to ChatGPT and say, hey, can we make buses free? And the AI will explain, here's how you can make a bus free. And they're like, no, it's not possible. It can never be done. And that brings up like the myth of government and whether or not government works for the people and whether we all put our money in a shared pile. My wife's family in South Africa does shared accounts. I think this is something that's more common outside the United States than it is inside. Everyone puts a few dollars in, and if someone has an emergency, they can pull from that shared family account. And I've always thought of government being like that. We kind of all invest, and then when someone needs to pull out because they need food or they need transportation, then that's their turn. And then one day it'll be my turn. And those are the kinds of problems that not solving them is a shared myth. It's not possible. We can't do it. Every other country in the world's done it, except we can't do it. It will be interesting to see people apply AI to problems of real problems of humans, and whether or not they'll push back and declare that no, we can't. The shared myth is too strong, or whether we'll actually dismantle some of these laws of fiction.
Yeah, and that's maybe even the most important point of the book, right? Is to empower us to look at the problems that we want to solve, and then instead of thinking, "Oh, what will be my future on Earth because AI is going to do my job," is really to think like, what is a job that I'm really interested in doing, a problem I'm really interested in solving, and how can I do that alongside AI, and make the world really better for everyone, right? And I think this will happen, but we want people to engage. And also, I'm glad that you talked about government, Scott, because like one of the points to me in the book is that I feel that maybe other areas like lawyers and economists have an oversized impact in politics in this country, and technologists don't have as much. But really, when we look at the impact of computer systems in our lives, I think we should have more and more people with background in computer science engaging in the discussion of systems in society, data in society, privacy in society, cloud in society, because this will be super important, right? So to me, more important, we of course we want to fix the economy, but like technology will be a huge factor in fixing the economy. And so I was hoping that also with my book I can encourage a new generation of leaders that have inclination for computer science, but also to think about societal problems and how can they use their expertise in STEM and science and technology to impact the world positively.
That's a great point. As they say, everything's a conspiracy when you don't know how anything works. And I learned a lot reading your book, Human Agency in a Digital World, and I appreciate that you wrote it.
Yeah, thanks so much, Scott. It was a pleasure writing it, and then I was super excited when you wanted to read, and you shared like very good insights with me. I'm very grateful to have your support and to be in this podcast with you.
Well, thank you so much. You can get the book anywhere that you buy books, Human Agency in a Digital World, and you can learn more about Marcus Fontoura at fontoura.org, Fontoura.org. We'll put a link to the show notes. And this has been another episode of Hansel Minutes, and we'll see you again next week.